In this video, we're going to do a process called rationalizing the denominator. So when you have a fraction with an irrational number in the denominator, what you can do is change it into the form with a rational denominator by doing a process called rationalizing the denominator. The reason we do this is because a fraction with a whole number denominator is easier to do operations with. Also, if these two solutions are both solutions, we can all agree to rationalize the denominator so that our answers look the same and we're not confused about whether or not we got the right answer. Finally, there's some historical context. If you had to do these problems by hand without a calculator, a rational denominator is much easier to work with. Whatever the reason is, we do want to make sure we know the process, again, so we can understand the work when we see it. So all you do to rationalize the denominator when you just have one single term in your denominator is you multiply by that exact term in a new fraction. So what we're doing here is we're multiplying the fraction 7 over the square root of 2 by the fraction the square root of 2 over the square root of 2. Remember that when you have the same thing in the numerator and the denominator, that's equal to 1. So really, we're multiplying this fraction 7 over the square root of 2 times 1. And when you multiply something by 1, you don't change the value of it at all. What that leads us to have in the numerator is 7 times the square root of 2. We can't simplify that at all. We can't multiply those together since we can't take the square root of 2 and order of operations say we have to square root before we multiply. So that is our numerator. In the denominator, we did a little trick here. So we took the square root of 2 times the square root of 2. You should hopefully recall that the square root of 2 squared, those are inverse operations. So when you multiply the square root of 2 times itself, or when you take the square root and then you square something, do and undo, you just wind up with the number 2. That works regardless of what number is under the radical, as long as it is the same number in both denominators. Now we have, instead of an irrational number in our denominator,